Okay, so today let's take a look at this LeetCode problem 713 subarray product less than K. So you are given an array of positive integers numbers. Count and print the numbers of contiguous subarray where the product of all the elements in the subarray is less than K. So this is the number of the numbers in the input array, and each number is between 0 and 1000 exclusive, and this is the K number. Okay. So obviously there is a big O(n) square brute force solution. We start from each element, and then we just try to expand it as much as we can. And every time when we expand to another element, we increase the count by 1, right? After we try every position, the counter will be the final result. But considering the size of the input, I think it will have the limited time exit arrow, but let's give it a try. So every time we're gonna product a new number, and then we do the check. If product is less than K, we increase the counter. Otherwise, we just break. We don't need to continue because all the numbers will be positive integers, right? Let's run the code. Yep, so I think it's gonna have the limit time exit arrow. Yep, so, okay. So the algorithm is right, but it's not efficient. So as I mentioned, it's gonna be a big O(n) square time complexity solution. So how can we improve this solution? And so let's say the input array is 10, 5, 2, 6, and we have a K currently is 100. So I'm thinking we can maintain a sliding window, right? We can maintain a sliding window which can be represented as by 2 index. Let's say this is our left boundary and this is our right boundary. So this sliding window will be maintained in this way. All the elements in the sliding window, within the sliding window, will have product less than K, right? And now when we introduce a new number, we need to keep the property of the sliding window. That is, after adding the new element, the new sliding window needs to satisfy such a requirement that all the elements within the new sliding window has product which is less than k, right? So in order to keep such a property, we can manage the I. We can move the I to the right, right? Keep doing this until the new sliding window meet the condition, right? Satisfy the requirement. Now let's say the left boundary is at I and the right boundary is at j. So how many subarrays gonna be introduced, gonna be added to the result? So I think the number gonna be j minus I plus 1 y. So let's say this is I and this is our new number which is j, right? So starting from each number, we can form a subarray that n at j. What I mean is, initially the I is here. We can form a subarray like this. Next time we move I to the right, and now we can form such a subarray, right? And so on and so forth. And also the new element itself can form a subarray. So you can see eventually the number of subarray that is being introduced is the number of elements between I and j, right? I and j. Okay, so having this in mind, I think we can just use the sliding window idea to implement a solution. Let's do it. Okay, we still need a counter. And the sliding window, we have left boundary, let's say I. And now let's just iterate the input array and meanwhile maintain the sliding window. So in order to maintain the subarray, we need to keep tracking of the product. So product will be the current product times the new number. Right, so after adding the new number to the sliding window, we need to keep the property of the sliding window, which is all the elements within the sliding window has product less than k. So if product is greater than or equal to K, right? And also I smaller or equal than J. What we do is we move the I pointer rightward by 1. And meanwhile, we need to divide the product by the current number. I mean, by the left number, right? So why we need I is smaller or equal than J? Because the minimal size of the sliding window is 0, right? When I is equals to J, let's put it in this way. When I, let's use another color. Or let's just copy the example here. Okay. When I and J point at the same position, right? This sliding window now has one element. But as we know, it could be the sliding window is empty, right? In that case, we still need to check this number. If this number is greater than K, we need to move our left boundary point rightward by 1. Right? In that case, J minus I plus 1 will be 0. So matches the empty array. Yeah. And now we just do increase the count. And eventually return the count. Okay, let's submit it. Okay, so this gonna be a big ON time complexity solution, and the space complexity will be big O1. We only created several local variable, and yeah, that's it.